Welcome to TSAT. Today I am going to discuss a topic in geography known as rocks. So here in the case of rocks, rock is made up of a combination of minerals. Rocks are being formed by the solidification of lava and magma. So the difference between lava and magma is both the source for both lava and magma is molten rock material. Because of high temperature and pressure conditions, rock melts. So here, when the molten rock is in the Earth's interior, which is not been exposed to the atmosphere, we call it as magma. When the magma erupts out and exposing out to the surface of the Earth, we call it as lava. So this magma and lava, when the temperature decreases, solidifies to form rocks. So, these rocks which have been solidified because of lava and magma, because of the decrease in the temperature, are known as igneous rock bodies. These igneous rock bodies or igneous rocks are otherwise also known as primary rocks or parent rocks, because these are the rocks which have been formed initially during the formation of the Earth, and this material, the magma which has formed into igneous rock bodies resulted in the formation of other different variant types of rocks because of different processes known as sedimentary rocks and metamorphic rocks. So, based upon the formation, the rocks are being classified into three types: igneous rock bodies, sedimentary rock bodies, and metamorphic rock bodies. So, here in this case of different variant types of rocks are considered. The way they have been formed, for example, igneous rocks are being formed by the solidification of lava and magma. These are also known as parent rocks because the other rocks are formed from the igneous rock bodies. So, in this case, these igneous rock bodies, when they are being subjected to certain processes of the Earth, they are being converted into sedimentary rocks and metamorphic rocks. So, both the rocks being formed by the solidification of lava and magma together known as igneous rocks. In the case of sedimentary rocks, the name itself says that the rock is the resultant of sedimentation. So, here what happens is, because of the process of weathering and erosion, what happens is the agents of weathering and erosion, like for example, the moving water, when it is moving from the higher elevated region, because of the kinetic energy the water has got, weathers the rock and erodes the rock. So, the difference between weathering and erosion is, in the case of weathering, means a larger rock particle becoming smaller particles is known as weathering. A smaller sand or gravel is known as weathering. And these smaller particles which have been converted from the rocks, which are being carried to different parts, different regions, is known as erosional activity. In this process of erosional activity, these sand, gravel material settle at the lowest place possible when the water is moving. In this process of sedimentation, a layer by layer, rocks are being, these sand particles, the weathered particles are being settled down layer by layer, which have been subjected to weathering and erosion. So, in this process, what happens is compaction happens because of the pressure, because of the weight of the different layers which have been sedimented, because of the pressure being built because of gravity. The sand grains which have been settled in the process of sedimentation are being compressed to form a single rock known as sedimentary rock. The cementing is being formed by the solutional activity of certain minerals like calcium, etc. When they have been dissolved from the higher elevated rock regions, acts as a cement between the sand grains, leading to the compaction of the sand grains, leading to the formation of a single rock known as sedimentary rock. So, the next rock is the metamorphic rock. Metamorphosis means change. In this process, what happens is, the change here is because of certain factors like temperature and pressure. So, here the change happened because of temperature is known as thermal metamorphosis, whereas the change in the rock in terms of their color, composition, texture, strength, sometimes even the mineral composition varies because of temperature is known as thermal metamorphism, whereas in the case of pressure is known as a dynamic metamorphism. So, there is a change happening in the nature of the rock, in its color, texture, mineral composition, strength, etc. because of temperature and pressure. This change in these natures is known as a metamorphic rock. So, igneous rock is known as a parent rock material because igneous rock can be converted into a sedimentary rock and igneous rock can be converted into a metamorphic rock also. So, in the rock cycle, I will be explaining you how one rock converts into other at the end of completing this the concept of rocks. So, based upon the source, the kind of minerals available, based upon the kind of sedimentary mechanism, temperature conditions, pressure conditions, even these three different variant types of rocks are being classified into different ways. So, different examples of igneous rock bodies has been projected to you. So, granite is an example of igneous rock body. For example, obsidian is an example of igneous rock body. Scoria, pumice are examples of igneous rock bodies. So, in the examination, they will be asking you different choices to identify different options being given to you, or they may give you in the match the following to identify different variant types of these igneous rock bodies, sedimentary rock bodies and metamorphic rock bodies, which have been formed because of these three different processes with which these rocks have been formed. In the case of sedimentary rocks, the limestone, shale, gypsum, sandstones are the classic examples of sedimentary rocks. In the case of metamorphic rocks, the marble, slate, quartz and gneiss are the classic examples of these different variant types of metamorphic rocks. So, fundamentally rocks are being classified into igneous, sedimentary and metamorphic, and these are the different variant types of these basic three different variant fundamental types of rocks. So, this variation is because of the way they have been formed in terms of the phenomena and even the mineral composition. Rock itself is an aggregation of minerals. So, these igneous rock bodies are being classified into two. One is intrusive igneous rock bodies and the second is extrusive igneous rock bodies. Intrusive igneous rock bodies means now you have come to know that igneous rock bodies are being formed because of the solidification of the magma. So, here these are known as intrusive because these rocks are being formed within the layers of the earth's interior without being exposed to the surface. These are the classic examples of igneous rock bodies. So, the pegmatite or diorite, gabbro are some of the examples of intrusive igneous rock bodies. So, even while framing a question, they may ask you out of these igneous rock bodies, what are intrusive igneous rock bodies and what are the extrusive igneous rock bodies. They may give you a question based upon this to differentiate examples of different intrusive and extrusive igneous rock bodies. So, there are certain examples being given here. So, basalt is an example of extrusive igneous rock body. Pumice, rhyolite, tuff, scoria are examples of extrusive igneous rock body. So, here in this case, what happens is the extrusive igneous rocks cool very fastly because they are exposed to air, whereas in the case of intrusive igneous rock bodies are not cooled very fast. So, because of this reason, the crystal size varies when you relatively compare with intrusive igneous rock bodies and extrusive igneous rock bodies. In the case of extrusive igneous rock bodies, the crystal size is very small or sometimes the crystals are absent. In the case of intrusive igneous rock, the crystal size is more. The more the time duration being consumed to solidified, the larger the crystal size in the rock is. So, these are certain points or the basis on which questions can be framed. So, from magma, which is the source of formation of certain minerals. So, there might be a question to you, what are the different kinds of minerals which are available from the source of magmatic rocks. So these are the different kinds of metallic minerals like iron, nickel, copper, lead, zinc, chromite, manganese, gold, platinum, and diamonds, where a diamond is not a metal, of course. So these are the different kinds of metallic minerals which are available in magmatic rock, and a question can be framed on this. So in the Earth's surface, we have got 2000 different minerals are found in the Earth. Out of these 2000 different variant types of minerals available, all the minerals are not evenly available here. Only 12 are common rock formers. So out of these 2000 different kinds of minerals, only 12 are common, and out of these 12, 87 of the earth minerals are silicates, which are a combination of silica. So on these 3 points even questions can be framed. So you need to keep this in mind, that the number of different variant types of minerals available in the Earth's crust, but very few minerals are responsible for the formation of rocks, which are known as rock formers. So here, when we relatively compare with the rocks here, as I have differentiated between sedimentary rocks, igneous rocks, and metamorphic rocks, when the surface area, on the top of the surface area of the Earth is considered, the extent of area occupied in terms of area, 75% of the Earth's surface area is being covered by sedimentary rock. Only 25% is covered by non-sedimentary rock. But when in a vertical dimension, when you are able to relatively compare, only 5% of the rock matter, when we go deep, is made up of sedimentary rock. 95% of the rocks are made up of igneous and metamorphic rocks. Even a question can be framed on this basis, in terms of horizontal extent, in terms of vertical extent, availability of these 3 different variant types of rocks. You need to keep this in mind. So the composition of, out of these sedimentary rocks, the composition of these 3, 8% in terms of limestone, 12% in terms of sandstone, and 80% in terms of shale, out of the different variant types of sedimentary rocks. The examples of extrusive igneous rocks: pumice, basalt, rhyolite, already we have discussed this. So intrusive igneous rocks, they have been, the way they have been formed, magma, when it has been solidified very slowly, because of which the crystal size is large, what I have discussed with you. So igneous rocks are formed both from magma and lava. That you need to keep in mind, because both magma and lava has got a source from molten rock. So in the case of this magma, which is in the Earth's interior, because of high temperature and pressure, because it is in a molten state, tries to escape out, to expose itself to the outer layers through the fractures and faults available in the layers of the Earth's interior. In this process, what happens is, the temperature, as it is decreasing, when it is trying to emerge out, with the decrease in the depth, when we go in towards the Earth's interior, the decreasing in the temperature and pressure leads to solidification of the rock sometimes before the magma comes out of the Earth's outermost layer. So in this process, the magma intrudes into the spaces of the fracture zones and fault zones. In this process, the rocks are being formed because of the cooling of magma, which have been intruded into the spaces available in the layers of the Earth's interior. So the solidified rocks will acquire the shape of the fracture zones, or the shape of the fractures, which might be horizontal, or which might be vertical, or which might be slanting, or any direction possible. So based upon the orientation of the solidified magma into these fracture zones, these solidified rocks from magma into these fracture zones are being classified into, or named as, for example, if For example, if a solidified rock is horizontal, we call it as a sill. If the solidified rock is in a vertical form, we call it as a dike. So, when it is horizontal, it is sill. When it is vertical, we call it as a dike. But the reason for the formation is the solidified magma. So, when it is in the form of a dome-shaped kind of thing, it is known as a laccolith. So, a larger structure which is being solidified with the help of magma is known as a batholith, which runs across some hundreds of kilometers sometimes. A small batholith is known as a stock. So, in the examination, he may ask you in a different ways. These are all the structures which I have explained to you are intrusive igneous rock bodies. Or they may ask you the difference between a sill and a dike. Or they may ask you to differentiate between a batholith and a stock. So, all these are solidified rock bodies from magma. So, here in this case, when it is in a dome shaped, it is called as a laccolith. When it is a saucer shaped, it is known as a lapolith. So, they may ask you to differentiate between a lapolith and a laccolith. So, these kind of structures are intrusive rock bodies. So, next is extrusive and intrusive igneous rock formations. One is outer layer of the earth and which are in the internal layers of the earth. The different kinds of minerals which are available here, as I have discussed in the case of igneous rock bodies, but in the case of metamorphic rocks, they may ask you what are the different kinds of minerals available in metamorphic rocks. So, they include anthracite, quartz, marble, slate, granulite, gneiss and schist. So, here in the case of this metamorphic, anthracite is considered as the purest form of coal. So, when the coal is being subjected to metamorphosis, it is being converted into anthracite. So, this can be asked as an objective bit. This already been discussed. The metallic ores derived from igneous rock bodies can be an objective bit. So, these examples of metamorphic rocks: gneiss, slate, marble, phyllite, schist, so quartzite. These are some examples of metamorphic rocks which can be asked in the exam. So, in this case of metamorphic process, what happens is with the increase of metamorphosis, for example, with the increasing in the depth, what I have already mentioned to you is there is increase in the temperature, there is increase in the pressure. So, because of these two factors of increasing in the temperature and pressure conditions, what happens is the nature of the rock varies in terms of the strength and nature, because of which one rock will be converted into a different type of rock. So, a shale is converted into slate, slate into phyllite, phyllite into schist, schist into gneiss. So, this is the sequence of formation of rocks. Once shale is a sedimentary rock. Shale is a sedimentary rock. When a shale is being subjected to metamorphosis of different temperature and pressure conditions, it gradually converts into different variant types of metamorphic rocks. The sequence can be asked as a question. Slate into phyllite, phyllite into schist, schist into gneiss. A question can be asked on the sequence of metamorphosis. See here. So, because of metamorphic process, the sedimentary rock, an example of sedimentary rock is sandstone. Sandstone, when metamorphosized, convert into quartz is an example. So, the other metamorphism is known as contact metamorphism. So, the magma which is present in the earth's interior, when it is in touch with the nearby layers, is being subjected to metamorphism. So, because the heat magma which is impacting the temperature to the above layers, subjecting to metamorphism because of contact, is known as contact metamorphism. So, dynamic and thermal metamorphosis, which I have already mentioned, because of dynamic metamorphosis is because of the pressure variations when the rock is changing its form and minerals. Thermal metamorphism is because of the temperature. So, in this process, granite turns into gneiss, clay and shale to schist. The next is sedimentary rocks. So, in the case of sedimentary rocks are formed because of the process of sedimentation, because of the process of weathering and erosion. So, the weathering and erosion of rocks are because of mechanical factors and because of chemical factors. So, mechanical factor is because of just sheer mechanical energy. The larger rock particles become smaller rock particles. For example, the moving water from the higher elevated regions to the lower regions from the mountains, what happens is the water has got a kinetic energy. This kinetic energy makes the rocks to crack subject to weathering and erosional activity. So, there is no chemical change or there is no change in the composition of the mineral of the rock. There is just a larger particle becoming a smaller particle. So, this is known as a mechanical weathering. So, sedimentary rocks, so sandstone, these are all shale or classic example which are the resultant of mechanical weathering. Whereas in the case of chemical weathering, what happens is there is a change in the chemical process because of the rocks being reacting with carbon dioxide, oxygen, etc. In this process, the chemical composition of the sedimentary materials vary. So, iron ore is being formed because of reacting with oxygen, etc. Flint, dolomite, and some limestones are classic examples of rocks which are being formed because of chemical weathering. So, they may ask you here in this case to in framing questions in terms of to differentiate different types of rocks which are being formed because of mechanical weathering and chemical weathering. These are different variant types of sedimentary rocks formed because of mechanical and chemical weathering. Coal and limestone are sedimentary rocks of organic origin. So, why these two stones have been classified as an organic rocks? Because these two stones or coal, for example, which is being used as a fuel, which is being converted into anthracite, graphite because of the metamorphic process. Because they have got source from living organisms. That is the reason why, for example, coal is being formed from plants. For example, limestone is being formed sometimes. The calcium because of solutional activity from the shells of mollusks when the calcium is being dissolved for cementing the sand grains, because they have got animal origin or living organisms origin. That is the reason why they have been classified as organic rocks. And other significant factor which can be asked as a question is, fossils are found only in a variant of rock known as sedimentary rocks only. In other variant types of rocks, fossils are not found. The reason behind it is, in the process of sedimentation, what happens is, layer by layer when they are being sedimented here, because of the process of weathering and erosion, what happens is these living organisms, whether the fish or the plant or the algae, whether it can be in the Indo-Gangetic plain, the sedimentation happening from the Himalayas, or in the case of an ocean, when the river is flowing, what happens is layer by layer when they are being sedimented, when these plants and animals die, they are being buried under the layers of the rock, subjecting to pressure and temperature. In the absence of oxygen because of high temperature and pressure, these living organisms are responsible for conversion into fossil fuels over millions of years. The petroleum is one such liquid fuel which is being derived from these living organisms, which are being trapped in the process of sedimentation because of temperature and pressure. So, fossils are found only in sedimentary rocks, whether it is coal, whether it is petroleum, these two are present, and in any fossils of animals and plants where archaeologists excavate are found only in the sedimentary layers. So, these are the basic features of the sedimentary rocks, which have got different layers because they are being deposited and cemented. Cracks, fossils are found, and concretion means cemented because of the pressure. That is the reason why these sedimentary rocks have got all these kind of characteristic features. So, the minerals which are being derived from these sedimentary rocks contain minerals like feldspar, gypsum, iron oxide, dolomite, quartz, and carbonates. So these are the different kinds of minerals derived from sedimentary rocks. So friends, so I have specified that the minerals which are being derived from the igneous rock bodies, the minerals which are being derived from metamorphic rock bodies, and the minerals which are being derived from sedimentary rock bodies. So questions can be from the source of mineral and the type of rock. Match the following into any types can be formed. So you need to learn the way to form or frame a question by observing the previous papers with the content being given to you. Rock cycle. So here in the case of this rock cycle, rock cycle, what we need to understand is one form of rock is being converted into another form of rock through this process which I have explained to you. For example, when an igneous rock is being subjected to weathering and erosion, what happens is it is subjected to sedimentation, and because of the sedimentation and cementation and pressure, it leads to formation of sedimentary rock. So when the sedimentary rock is, because of magmatic activity, when it is being melted, it can be converted into igneous rock body. So there is possibility of conversion of one rock into another rock. In the same way, when the igneous rock body is being subjected to dynamic metamorphism or thermal metamorphism, this igneous rock body can be metamorphosized into a metamorphic rock, and a metamorphic rock when melts can be converted into an igneous rock body. Metamorphic rock when subjected to weathering and erosion can be formed into a sedimentary rock. When sedimentary rock is being subjected to metamorphism of thermal metamorphism or dynamic metamorphism, sedimentary rock can convert it into a metamorphic rock. So friends, this is about rocks, and I will be discussing with groundwater and karst topography in the next episode.